Right, for this section, we're going to talk about logarithmic functions. Uh, and we always do logarithmic functions with exponential functions back to back because they have an algebraic relation. If you look over here, for logarithm, we're going to use log. Logarithmic function will have a base, so it's log base b of x is equal to y. If they give me a logarithmic function and I couldn't really solve it, it's too hard to solve as a log function, I can change it into an exponential function. So in the way it goes is like this: base b to the y is equal to x. And vice versa, I can go back and forth. If they give me an exponential function that's too hard to solve, I can change it into a log function, and that might be easier. So this is basically what we're going to use when we solve equations. Some other stuff, natural log is ln, and that's really a logarithm. It's an log base e. Instead of writing log base e all the time, we're going to use ln. That's natural logarithm. Okay? So if I'm looking at ln of x equal e, I need to remember ln is a base e. So I can change this into an exponential equation. It's e to the y is equal x, and vice versa again. Common log, when you see an log with no base on the bottom, you don't see a number on the bottom, that's understood to be a 10. So the common log is a base 10. And if I want to make the exchange, it's 10 to the y equal x. Okay? All right, let's do some examples. It says, write an exponential form. So I'm given log base 4 of 16 equal 2. To change it into an exponential form, the base is 4. So it's going to go like this. 4 to the 2 is equal to 16, which is true. 4 squared is 16. This one, b to the 5 is equal to 7. Now this one, it says ln, so I know that's base e. So it's e to the 3 is equal to c. Now we're going to go the other way. We're going to change from an exponential form into logarithmic form. So the base is 2, so it's going to be log base 2 of 1/8 is equal to -3. This one here, that's a base 10, so that's a log. I don't have to put anything because that's a base 10 if I don't put anything. Is equal to 0. E to the, that's a base e, so I can write natural log ln of 12 is equal to a. On the next page, we're going to actually evaluate these algebraically. We're not going to use a calculator. So for the first one, it says evaluate log base 3 of 81. Well, to do that, I'm going to change it. Let's call the answer is x, for example. I can do it as a log because I don't have a calculator, but look, I can change this into an exponential function. There's the base. 3 to the x is equal to 81. Now it's an exponential equation, and to solve an exponential equations from the previous chapter, I need to fix the base if I can. It's a base 3. Can I write 81 with a base 3? Yes, it's 3 to the 4. Now it's the same base, equal sign. That means those powers are equal. So x is equal to 4. So by changing it into an exponential equation, I can solve it. I'm going to do the same thing for number 8. I'm going to call it equal to x. Then I'm going to change it from log into exponential. So it's 8 to the x is equal to 2. Or it's a base 2, so I can change the 8 into 2 to the 3 times the x equal 2 to the 1. Same base, equal sign. The rule says you take those powers and you set them equal to each other and you solve it. So in this case, the answer is 1/3. Same thing for number 9. I have log, that's an ln, so that's log base e. Let's call it equal to x. So base e, so that's e to the x is equal to 1 over e to the 4. Everything needs to be on the same level, numerator, so I'll bring this one e to the -4. I'll bring it up. I changed the sign on the 4. So I have e to the x equal e to the -4, same base, equal sign. The rule says those powers are equal. So x is equal to -4. This one over here, let's call it x. So now I have log base 5, so that's 5 to the x is equal to 1. So for this one, I couldn't fix the base, but I need to remember anything to what will give me a 1? Anything to the 0 power is 1. So in this case, x is equal to 0. Number 11, so here we go, let's call it x. So that will give me 5 to the x is equal to 5 to the 8. Same base, I don't have to do much with this one. The rule says those powers are equal, so x is equal to 8. Same thing over here, I have 9 to the x equal 1/3. So the 9 base will change it to a base 3, that's 2 times the x. I'll bring this one up because this is 3 to the 1. By doing that, same base 3 equal sign, the rule says take those powers, set them equal to each other, and finish the algebra. So x is equal to -1/2. On the bottom, we have log base 4. Let's say we'll do the same steps. 4 to the x is equal to -4. Okay, so I can't really do this. I need to, I should, I cannot take the log of a negative number. Here's the parent, log base x, log base b of x. And so this is not possible because the domain of a log function of log base b of x is from 0 to infinity. So it's a positive numbers. So I cannot take the log of a negative number. So remember that. The log of it doesn't matter what the base is, log of a negative number is not possible because of the domain. Okay. All right, last one. I don't see a base here, so that's understood to be 10. So I have 10 to the x is equal to the square root of 10. So that's 10 to the x equal. We need to change this radical. That's a square root index 2. So this is, and there's a 1 here. So this is where you change it into a power. 10 to the x equal 10 to the half. Same base equal sign. X is equal to a half.